Hello, everybody, and welcome to another episode of Connect's Conversations. Today's conversation is all about Tools RCM and is brought to you as a part of MOBIUS Connect's ongoing YouTube series, Connect Conversations. I'm Kim Huger, the manager of MOBIUS Connect, and I will be your moderator for today's session. First, I'd like to take a moment to introduce the hosts of Connect Conversations series, reliable improvement experts Doug Plucknette and Ron Moore. Don and Doug, are you there with me?
We're here.
Again, I said Don. Doug. Okay, fantastic. Well, before I pass the microphone over to you guys, I want to encourage our audience here today to submit any questions that you have into the comments here, and we will have Doug and Ron answer them live on the air today. So this is an interactive conversation, so please, at any point that you have questions, enter them in. All right. Doug and Ron, I'm going to go ahead and pass things over to you now.
All righty. Thank you. Doug, you want to start? You want me to start?
Oh, let's see. You can go ahead and start, Ron.
Okay. Well, we're talking about RCM, reliability-centered maintenance. I've had a friend of mine, he called it reliability-centered misery. And another guy, resource-consuming monster. So we hope today will alleviate the fear that it will become that. And we hope to give you some tips about how to do that. Now, Doug is the expert. Okay, he wrote the book RCM Blitz. He's conducted lots and lots of RCM analyses and so on. There you go. Plug your book, Doug. And I think Doug's book is probably the most practical book in the application of RCM of all of them. And I've read at this point 4. So there's a bunch of them out there. But if you want a good, nice, practical application of RCM, I think Doug's book is the best. So, and I don't say that. I don't say that because he's a friend. I say that because it's the truth for me, at least. So, and you're welcome. I'll expect to check in the mail here later, bull crap. But anyways, I did want to make 2 or 3 comments. Now I'll let Doug, take it over because, like I said, he's the expert. When I think of RCM, the way my little hillbilly mind processes it as follows. Number one is, what's the system supposed to do? What's it supposed to do? And be very specific. 100 gallons a minute at 100 PSI with no leaks, is a real simple example. So define the functional requirements. What's the system supposed to do? And then the next question in my hillbilly mind is, what's stopping it from doing that? That is, what are the failure modes for each of the functional requirements? And then the next one is, which one's hurting you the most? That is, which one has the highest probability and consequence relative to the failure modes and the functional requirements? And then the last one is real easy. What are you going to do about the things that are hurting you the most? What tasks are you going to put in place? What actions are you going to take to stop those failure modes that are hurting you most? So I think if you could think that way, then you kind of got a pretty good handle on RCM that's not too complex. Now, it gets more complex as you get into it, as Doug will, I'm sure, tell you. But what's it supposed to do? What's stopping it from doing that? What's hurting you the most? And what are you going to do about the things hurting you the most? So that's my very simplistic hillbilly version of RCM. Doug, over to you.
Well, your version is pretty spot on, Ron. Here's the deal. I got involved in RCM. I want to say it was 1995, and I was back working at Kodak, and I got involved in a team they were calling the reliability group in Kodak Park, and we had a couple members from each division, and we would meet once or twice a month and talk about different stuff. And we first got talking about reliability measures, what are the things we should measure. Then we started talking about different things you could do. And then the tools came up, root cause analysis and RCM. And So we put together teams on researching those and what types of applications, where would they apply, where should it be used. And this was even well before even saying, let's go ahead and do one. It was really, what is it, right? And so I got selected for both of those teams, in fact. And so we picked a provider for root cause analysis, and that worked out quite well. And then we picked a couple for RCM, and I went to some training on those, and we did some pilot RCMs, and they just seemed to drag on forever. And when I'm saying forever, 3 to 6 months to get one system done. And I just kept shaking my head saying, there's got to be simpler than this. It's not that complex. And at that time, the standard for RCM, the SAE standard, didn't exist. That was, in fact, just getting started to get developed along with SMRP, as a matter of fact. And I got a little bit involved in that team. But anyway, I kept looking at it and saying, this really is a simple process, right? It's just a number of steps and do them in the right order. And it simply takes a little bit of discipline to get it done. And so
you were doing the reliability centered misery version. But tell us how you fix that.
And in fact, it was a resource consuming monster at the time as well. Because when you take that long, more and more people get involved, and gosh, they had 10, 12 people sitting in on these things and all talking about what we'd spend the first 20 minutes of each meeting talking about what we talked about in the last meeting, right? And it just was taking forever. And then, at night school, I had the professor introduce me to Nolan and Heap's document, and I sat down and started reading that and digesting that and saying, my gosh, this is far more simple than what we're doing right here, right? Here's the steps to it. As you said, identify the function. What are the functional failures? What are the failure modes? What are the failure effects? Why do we care about each failure mode, right? What are the consequences? What's the probability? Then get into developing tasks and then say ranking those things. So when we go to implement. And so it really came down to, there's 7 or 8 steps to this. We ended up adding spare parts to it down the road, saying, no maintenance strategy is complete without the spare parts. We should be talking about those as well. And the next thing you know, that's kind of where RCM Blitz was born out of. A guy that I was working with, I think that you knew, Jerry Haggerty, said, hey, if we're going to get involved with this, we need to go to corporate and talk with them and make sure we're not infringing anybody's copyright or trademark. And so I went and did that. And that's kind of where I learned about copyright and trademark and made the decision. I think I might have something going on here. And that's right along the same time that I started planning to leave. So we did some pilots, probably, 5 or 6 over the next 6 months, and they all worked out great. And those are the things I think more than anything that I pass on about RCM. And I think the number one question that I get from people is, why do companies struggle with it? There's been different studies that have said in the past that 70% of the companies that start RCM don't finish it, right? And I can tell you my numbers are better than that. Some years it's been as high as 85% success rate. Other years it's been as low as 65, right? It really comes down to, I always say there's 3 things: leadership, structure, and discipline, right? So you have to have your leaders involved to the point where they're going to help you select what are the right things to work on. I'm a person that's always said, use your reliability measures to figure out what you want to work on. Don't go on emotion. Otherwise, you'll be working on what was today's biggest problem. And that's not what RCM was built for. So use those reliability measures like OEE. Ron and I have talked about that several times in the talks that we've been doing. And look for critical assets where the OEE is struggling and their equipment-based losses, right? So if you start there, you should be successful. Why do companies fail at it? Because they don't follow through. Let me rephrase that. Starting out, they don't get told the truth about what RCM is and what kind of resources it should take to do an RCM analysis. You don't need 10 or 12 people involved in an RCM. You need between 3 and 5 typically, right? And if that RCM analysis is going to take you 5 days to get it done, to complete just the analysis, you should plan on 3 weeks to implement what comes out of that analysis. So if it takes 3 days, it's going to take 3 times that, 9 days to implement what you got out, right? And you need to set those resources aside to do that. If you don't do that from day one, and that's where it comes in, and Ron and I have talked about this in the past too, set your plan up front, right? I don't care whether you call it a contract or some other fancy word for it, but sit down and say, here's who needs to be involved, and here's the time it's going to take for them to do this. Here's who's going to facilitate. Here's who's going to participate. Here's who's going to implement. We need these 3 people to implement. Right?
Yeah, let me put something in here, Doug, to reinforce what you just said. You know, when I talk to people about RCM, like I said, I'm not the expert, but when I talk to them, I say, look, if you're going to do this, you need to budget 3 or 4 or 5 times as much money for the execution as you do for the analysis.
Yep.
And maybe it's 2 times, maybe it's 1 times, but the point is, you're not just going to do the analysis and you're done. That's just the start. You're going to need, 3 or 4 or 5 times as much as that to actually execute on what you find. And that's not a magic number. It's just a rule of thumb.
Sure.
Maybe 10 times if it requires a lot of capital equipment, maybe 1 time, but make sure you set the expectation around the fact that to actually implement the analysis is going to cost you money. And the second comment I had, you said 3 or 4 or 5 people, and I agree with that. I've done some work relative to teams and effective teams, and the optimal number for a team on a relatively difficult problem is somewhere around 4 to 6. If you got more than that, even if you got 6, 1 or 2 of those guys is going to be like a fifth wheel. They're not going to be very productive. They're not going to contribute very much. So you got 12 guys in a room working on a problem. 6 of those guys aren't contributing. So those are my comments, Doug. I'll turn it back to you.
All right. The second thing that causes them to fail is they don't implement, right? And implementation, again, is really just a function of resources, right? You need to set people's time aside and identify who those people are going to be to do that, right? Typically, folks that are good at doing this are folks that are in the planner role, right? They've written procedures before. They know what it takes to write a PM procedure. They know what it takes to put in a repetitive job, such as vibration analysis or performance thermography. You're typically going to need some time from an engineer because there, in most cases, a bit of small capital that comes out of every RCM, right? So you need somebody to set aside that can write small capital and work through the management of change process. You may need somebody from operations, a bit of time from somebody in that side of the group to put together standard operating procedures on how we start up, shut down, do product changes, those types of things. So identify those people up front and make sure they have that time. Companies that do that find out that, heck, they can get their RCMs, do one the first week of the month, and over the next 3 weeks, have the thing completely implemented, or I say 80 to 90% implemented, because the small capital is going to take a little bit more time to get the money approved, to get the MOCs written, but the bulk of it can be done within 3 weeks. And when I first started doing that, people were saying, oh, no, that can't happen. That can't be true. But when you take the time to tell people this up front, right? And when companies learn that, they're like, holy smokes, this is a lot easier than, we tried this before and we struggled with it. It was terrible. Well, it doesn't have to be that way, right? You have to understand what you're looking at up front and plan on how you're going to do that, right?
Yeah. Let me just throw in another comment on that, Doug. You mentioned operations. In a production plant, I really think that most of these RCMs must have a senior operator or an operating supervisor, somebody that knows the operating context so that they can tell you what's important to the operation, how it operates, and so on. Otherwise, you may go down a trail focused on the wrong thing and wind up going, uh-oh, oops. So I think it's really important to have somebody who's familiar with the operating process participate in the analysis. As appropriate, not everything requires that, but in a production plant, more often than not, you need somebody from operations to help guide the process and give you operating context and environment and what's important to operations. So,
and I can tell you, Ron, that I ask for a hands-on person to do that. The person that's actually operating the equipment.
Yeah.
Right. I don't want a supervisor. I don't want a product engineer. I want the equipment operator, the best one you got, preferably. Right. Yeah. Set their time aside, whatever you got to do to have them so they're in there on the day shift, the week or the time that we're doing this. Because not only do they know best about what's going on with that equipment, they're also going to know some of the little things that the operators themselves do to get by on a day-to-day basis. And the maintenance guys are always typically surprised by some of the failures that they deal with that maintenance never finds anything about. Right.
Yeah. Just a point of clarification there yet to reinforce what you just said, and that's this. If you get an operating supervisor or somebody like that, it has to be somebody that's actually operated the equipment, not just somebody that's been appointed supervisor and they don't have any background. All they're doing is the administrative and, supervisory stuff, and they don't have any experience with the process of the equipment. So, yeah, amen to what you just said.
Yeah. And I'm always amazed at some of the things that, we've come across in working with the operators and speaking with the operators, and some of the ideas they've had that they just haven't been able to get their point across. Others, I worked with an auto manufacturing plant a few years back where their operator said, man, I have this daily checklist that they had me go through, and I had no idea, wanted me, look at this and check it off. And he said, I've been doing that for 2 years, and I had no idea why they wanted me to look at that stuff. Right. And it get to a point where if you look at the same doggone thing every day, you stop looking at it. He goes, now I truly understand why it's important for me to look at these things and which ones I really needed to look at and which ones were really kind of shouldn't have been on there in the first place. Right. So that type of communication goes on, and it creates a level of respect between the two groups, right? Which companies often struggle with is when they have those in the room, all of a sudden they realize, hey, we really are on the same team here, right? We're looking to accomplish the same stuff. And if you're struggling with something and we don't know about it, we can't help you. Right. So that type of communication works out big. Other reasons why companies struggle with RCM, and I alluded to this early on, is they tend to make emotional choices for what they want to analyze, right? So I'll come into a place and train facilitators. Okay, what are we going to work on with our first week out here, where you're going to do your first RCM, and they won't have a clue. Well, they haven't been looking at measures. They haven't done a criticality analysis. So what do? They say, let's pick this because we had a big problem with it 2 weeks ago. Okay. So prior to 2 weeks ago, what other problems have you had with it? Well, not a lot, really. Right.
Well, just my
And-
own
and
little
he-
war story on that, Doug.
Right.
I was at a LNG plant on the island of Borneo, Malaysia, just off in the middle of nothing. Anyways, I asked the site manager, what's your biggest problem here? The one that caused you to lose the most production? And he said, well, we shut the entire plant down one time. And I said, okay, when was that? And he said, 5 years ago. And I said, what was the issue? He said, well, we had a power interrupt on the grid and it got into our instrumentation and tripped everything. But he wanted us to do the analysis on that thing that happened once in a blue moon that shut him down. And, I said, well, you better go back to your power supplier to fix that. I don't think we can do anything about that here. So depending on who's got the biggest burr in their saddle about an issue, you can be directed to kind of the wrong thing. So anyways, that's my little war story.
And things like that, that's a great failure to look at with root cause analysis when we're dealing about a single event that occurs once in a great so often, right? RCM is really about, let's look at the equipment as a whole. What could happen as opposed to that one thing that did happen, right? So what could happen and what do we need to do to mitigate that? What's the best choice in terms of maintenance, right? Do we need to do a PM on it? And PM, as you and I have pointed out many times on here, doesn't apply to a lot of things. It tops 11% of your equipment, right? Is it a condition-based task would be better suited? Is there a redesign that would eliminate the failure altogether? Is this something we're going to run to failure? And then we look at how can we reduce the consequences if that's the case, right? So there's a number of different options here, and that's what RCM is really about, is saying what's the best strategy to maintain that inherent design reliability for that piece of equipment or that process.
Yeah, I've got a question for you, Doug. It's a comment and then a question. One of the things that I sort of discourage people from doing is when they're doing one of these analyses is go searching for all possible failure modes. And, if you do that, man, you can, well, if a meteorite hits, this eastern part of the US, then, well, so I kind of discourage searching for all possible failure modes before you've addressed the ones you know about. Now, the exception to that, because there are exceptions, and then I'll ask you a question, what's your view? The exception to that would be, for example, if you're, doing an RCM on a cyanide pump, well, you probably ought to look at potential failure modes.
Right.
Or if you're designing a 797 that's going to be across the Pacific, you can't get halfway across and go, oh, we didn't think about that, So, or if you're sending somebody to the moon, right, you've got to consider, essentially all possible failure modes, because you aren't going to be able to take action, when you're halfway to the moon and something goes, oops.
Yeah.
So anyways, your comment, again, I encourage them to focus on what they know. And, if it does have some potential for occurring, consider that. But I kind of discourage searching for all possible failure modes. Do you have any comment on that?
I'm the person that's, I use the wording, what has happened, what's reasonable, what's likely, right? And let's discuss that. If it's highly unlikely, unless the consequences are severe, we're probably not going to talk about it. Right?
Or if you can't do anything about it,
right?
If you can't do anything about meteorites, you can't do anything about hurricanes necessarily. You can, build in some, So anyways, go ahead. Sorry.
So, and those are issues that we have with every team and with every company. I talk about when I do training, I use a guy's name Larry, right? That I worked with a Larry years ago, and Larry liked to go out in the weeds and hunt for stuff, right? And he wanted to talk about every nut, every bolt, every washer, right? And he'd like to talk about things that vibrated loose. And I say to him, Larry, did we tighten it right in the first place? All right. If we use torque specifications and we tighten things properly and we use the right materials and we use the right, can we make those assumptions that we're doing that? And
Not
he'd say,
necessarily.
and that's what he'd say. He goes, well, I guess that depends on where you are. Well, if you're not torquing stuff, then yeah, we need to talk about torque. If you don't have the right materials, then we need to talk about we need the right materials. But we
Right.
can end up going every single nut, bolt, washer, screw in this plant, right? How many times we got to talk about it?
Yeah.
Right. Before you say to yourselves, all right, maybe this is a training issue and we need to train our people on what are the proper materials, what are the proper torque specifications, right? How do we assemble this properly? If you're not doing those things right to begin with, is that a function of a maintenance strategy or is it a function of training?
Yeah. Well, doing RCM to that level, probably not going to help you much. You're going to get bogged down and never finish.
Sure. And those are the things I tell people. You'll see in there that I have training tasks, and if we need to train people, then let's identify that and we'll get that training done. But if we don't do that, then we are going to have to talk about every single bolt, screw, washer, nut, right? You name it. And it's going to take us forever.
Yeah, as you know, I've wrote this book, What Tool When, and what tool when you start with the basics, standard work.
Yeah.
Right. Which would mean nuts get torqued,
Yeah.
and you have process control limits and all that sort of standard work, and you work to that standard. You do the basics right. 5S, 5Y, standard work, go and see. If you do all that, then you'll eliminate a lot of problems that won't need, a Six Sigma or an RCM or an RCA. You'll eliminate just a truckload of problems, and you'll build in the discipline within the organization to do and sustain whatever you find in the analysis. So that, to me, doing the basics right first is kind of a preamble for some of these more advanced tools.
All right. Next issue that I deal with is we'll go somewhere, do an RCM analysis, they'll implement it. They'll see a tremendous change in OEE. They'll have a big celebration. And then 6 or 8 months later, they're right back where they started. What happened?
They didn't have standard work. So they didn't upgrade their standards. But go ahead, Doug. I'm sorry.
Yeah. Well, here's the deal. I tell them, well, did you implement it? Did it get put into your CMMS so that those jobs come up as they were supposed to every month or 3 months or week or whatever schedule we said they needed to be done? Is that happening? And sometimes I get the blank look of, well, no. Oh, so you went and you did all the stuff that we recommended once and you got that change, right? And then you didn't do it after that. Sometimes that happens, right? Sometimes they get a change in leadership and they change their focus, right? Well, we implemented all that. It got put into the CMMS, and then we got a new manager, and the new manager said, we don't have time to do all that stuff because we got all these fires to keep fighting, right? This can be a struggle, and I tell companies, and sometimes it's my own fault because I'll say to them, with their managers, when we sit down and we first start talking about this, and I say, there's going to be a lot of work that comes out of this RCM. And there's going to be a lot of people that say, we don't have time to do this. And my reply back to them is, you haven't had time forever. right? I want you to focus on one asset. And if you can't do it on one thing, you'll never be able to do it on anything. So let's focus on this one thing right now. You'll see that it works. And if it works, then you'll want to do it on some other things. I can't not tell them that you have to continue doing it on that one. Right?
Well, you have to
You'd be
standardize it.
surprised. Yeah. It's just what you said, right? It has to become a daily standard, monthly standard, weekly standard that this is going to get done. Right? If it doesn't get done, and that's how you always say, you know, the old elephant, this is how you eat that elephant. It's one bite at a time. We're going to start this RCM. I don't want you to do it on your whole plan. I want you to do it on one thing. I want you to show it successful. Once you show it successful, then you can move on to the next thing. Right? And when you've done 5 or 6 things, now all of a sudden you'll start to feel the difference in that emergency demand workload if we're working on critical assets. Right? When you don't work on critical assets, then all that goes out the window and you don't feel that change. You don't see that change in availability for people to go out and do the right things.
Yep. One thing I wanted to mention here, maybe it's an appropriate time, just check the time we got left. I actually, from time to time, do what amounts to a plant level RCM analysis.
Mm-hmm.
You know, FMEA, if you want to call it that.
Sure.
So that helps me in the for what it's worth category to the folks listening. It helps me narrow the focus on where the money is, you know, where's the money and where we need to focus our energy and the appropriate tools. And I learned how to do this or develop this while I was trying to learn about RCM. You know, functional requirements, failure modes, consequences, and task, and all that sort of thing. But, you know, we'll draw, say, a production line or even a plant, draw a block diagram. And we start out by defining a functional failure as anything that causes you to lose production output.
Yep.
Anything. Doesn't have to be the equipment. And, you know, we'll go through this and, you know, let me just give you an example. We've got the block diagram, got cross-functional teams from the area or the areas. And we start at the beginning. What's your biggest functional failure here? Causes you to lose most production. What you typically get out of one of those analyses is, well, raw material supply. Well, what's the problem? Well, we don't get any. Okay. Or we get it and it's not good quality. Okay. Well, what's that worth to you in terms of lost production, gross profit, the quality, you know, whatever it is, make some notional estimate about what that is. And you got a number. What's your next biggest one? Well, operator no-shows. Oh, okay. Well, what's that worth to you? How often does that happen? You know, and you just go through and you put together some estimates on that. You know, what's your next biggest one? Well, shift handover. We shut the process down during shift handover. Oh, okay. Anyways, what I've found when you do one of these at a production line level or a plant level, what I found is that most of the production losses have nothing to do with the equipment.
Yeah.
You know, it's more about the production process, the raw materials, the changeovers that take, you know, eons to do, you know, it's that sort of thing. Now that we've got that information, now we can selectively apply the appropriate tools. Now, yes, sometimes it is the equipment. You know, it hadn't been looked after, hadn't been taken care of. So you got to restore it and put processes in place. But anyways, that's just a application of RCM principles at a very high level to help narrow your focus to what, you know, where the money is. So I'll turn it back to you.
And that, by the way, is enlightening for so many people when they start measuring OEE and they look at where their losses actually are, right? And they find out that, you know, holy smokes, if you ask them up front, how much do you think your equipment losses are actually due to maintenance and breakdowns, they're going to give you a number typically around 35, 40%.
Mhm.
And in reality, they find out in most cases it's somewhere around 15 to 18%, right? Even that would be high,
Yeah,
right?
I see about notionally about 10% relative to OEE controllables.
Yeah. And they're amazed by some of the things are so easy to deal with, right? In terms of the other losses that they kind of just all of a sudden go, wow, we've had that sitting right in front of us and never were really aware of it until somebody measured it. So,
Yeah.
Back to RCM and why companies struggle. Another reason is they don't understand failure modes. They don't talk or speak at failure mode level. Therefore, they do not work at failure mode level. And they're confused when I first start talking about this, but I'll say to the managers, it's not uncommon for me to come into a plant, we'll start talking about RCM, and I'll say, gee, the next component we're going to talk about here is this pump. What are the failure modes of this pump? And somebody will say, well, the pump failed. Why
That
did,
narrows it
why
down.
did, why did it fail? Well, it wouldn't turn. Why wouldn't it turn? Well, because the motor kicked out. All right. So are we talking about the pump or the motor? Because I thought we were talking about the pump. That's the motor you're talking about. We will talk about the motor. Is there a reason why the pump fails? Well, the pump bearing seized. Why did the pump bearing seize? And then they start to get quiet, right? And you go, all right, is it a lubrication issue? Well, yeah. All right, what's it lubricated with? Quiet again, right?
Grease.
Is it oil or grease, right? And when you say to managers, if they can't identify at which level your equipment is failing, they can't help you prevent it. They can't help you come up with ideas of saying what's the right thing to prevent that from happening again. Right.
Well, you're
And
reinforcing.
therefore,
Sorry, you're reinforcing what I encourage people to do. The basics, 5 whys.
yeah,
You just did 5 whys, right? To try to get
yeah.
to narrow the focus. But
And,
so anyway,
and that's one of the jewels of doing RCM and root causes is they're complementary tools. Once you start doing one, you'll get better at the other, and vice versa. Right? If you do more RCMs, you'll get better at root cause. If you do more root cause, you'll get better at RCM, because then we start talking about what failure modes actually are. Right?
Yeah.
Until you do that, and I tell them, I can guarantee you at this plant, in the last year, you probably changed more than a dozen motors that weren't failed, more than a dozen gearboxes that weren't failed, more than a dozen pumps or blowers or compressors that weren't failed, but you replaced them because that's what the person thought it was when they came in. Whether an operator told them it was the pump that was failed, they'll change the pump. And then they'll go to turn it back on, and the pump won't turn. They'll go, holy smokes, it wasn't the pump, it was the motor. Do you think they take the pump out? The one that they've just put in and put the old one back in? Nope, they replaced the motor. So you just paid for a pump and a motor when you only need to pay for the motor. Right? And this happens continuously. And when I do RCMs, I ask them about that, and they'll sit in the room and chuckle about it. And they'll say, well, what would you do? Right? If you don't know, right, the objective is get the process back running. That's what I'm told is the most important thing. And I don't have time to go take the good pump out that I just put in, put the pump that wasn't failed back in, and then replace the motor. I'm just going to replace the motor. Right?
Yeah.
When in reality, as you said, the basics are where we've fallen down. Identify for a fact what the problem is before you take action.
Yeah. One,
Right.
just another, excuse me, war story, and you can apply this too. In fact, the folks listening can apply this. I had a call from a guy named Joe Wansettler at big US, not US Steel, but a big steel company. And he said, Ron, I'd like you to come up and do a RCM analysis on the scarfer. Well, I don't know if you know what a scarfer is, but it's a big, huge box-shaped blowtorch. It runs about a foot and a half thick and about 3 or 4 feet wide, and you slide slabs of steel through it, and it's got little burners about every centimeter that literally oxidize the top millimeter or so of steel to prevent surface cracking. And he wanted me to do an RCM. Well, first of all, I'm not competent. Secondly, I don't enjoy it.
You should.
I'm glad you do, Doug, but I don't enjoy it. And so I said, well, let me get Bill Steele. I didn't know you very well at the time. So I got a friend of mine, Bill Steele, to come up with me. And we got there and I said, well, now, before we do this RCM thingy, I want to go talk to the operator about, the scarfer. And I went out and said, what's the problem here with this thing, all this maintenance? He said, well, one of the problems is the coolers for the scarfer, they get clogged up and it gets hot and it droops and it fails. No, it gets hot because what? Well, we don't change the filter. The filter gets clogged up and cooling water can't get through. Oh, okay. Well, maybe there's a PM needed there. But he said, but the biggest problem is I get crooked steel from the rolling mill and it bangs into and it rubs and it bumps the scarfer and damages it. I said, oh, okay. So you go up to the rolling mill and you say, what's the problem? You can't send him straight steel. He said, well, the slabs coming out of the ovens are cold on one side. So when I roll it, right, it comes out crooked. and it damages the scarfer. And I go up to the ovens operator and I said, what's the problem? You can't send him uniform temperature slabs, ingots. He said, well, the supervisor told me to leave the tops off the ovens to get better, faster production. And cold air goes down the side. Now I get them out of here faster, but they're not uniform temperature. There you go. And I'm a genius.
It's amazing what you learn when you talk to people, isn't it?
Yeah. So the point there for anybody that wants to listen is go talk to the guys doing the work and find out what the hell is really happening with the equipment and the process.
Yeah.
And then go apply the appropriate technique or tool. Now I left, I just said, okay, I'm done. Bill, you go ahead and do the analysis and do whatever that, shows up. But first thing you got to do is put a PM in to change the filter.
Change filter.
And the second thing you got to do is get the guy doing the work up there, the supervisor, to stop taking the tops off the ovens. So anyways, and I just hit something that made my picture.
You disappeared.
I know. I see. I don't know what to do about it. I bumped a key here. But anyways, you keep talking and I'll figure it out.
All right, I'll do that. So once we get to the point where we get people to understand what failure modes are, there's also an enlightening that occurs where they can apply it to other things. And that's kind of the first step change of RCM that I tell companies is you're not only going to see the benefit of the one thing that we've worked on here this week, you're going to see down the road that people start thinking about and discussing failures in different terms. Right? They'll start talking about why things fail and what caused them to fail and what things they can do to deal with that. All right. Last problem I want to talk about in terms of why companies struggle with RCM is when we get to the RCM analysis and we start talking about the different task types, we get to condition-based maintenance, where we're talking about things like thermography and ultrasound and vibration analysis and motor current analysis and all the different tools that are out there. And you'll find out, well, we don't have but 2 of those 5 things that you just talked about. Right. Well, there needs to be a step change that occurs here, right? Those technologies offer a lot in terms of identifying failure modes while they're in the process of occurring. So while they're in that PF curve where we can identify them, plan, schedule, and replace the item before it completely fails. And therefore, we can save you a ton of money in terms of secondary damage, right? So how do I get people to invest in those, to spend that money so they get the most out of their maintenance strategy? So they're not just stuck relying on PM, which is what they've been trying to do for the last 60 years, right? And it only applies to a small percentage of things. And so therefore they struggle and they end up in this terrible thing where they've got all this weight of this emergency demand work that they're having to deal with on a daily basis. Well, that's not going to change until you get to start doing the maintenance that comes with understanding how your equipment works and what you can do to prevent or predict those failures. With that understanding, by the way, that many of the things that we discuss in the RCM in terms of those technologies, you're going to discover that, hey, we can eliminate those failures to begin with, and we don't need to do that, this or that, right? And you'll look at me and you'll say, well, if we use precision alignments and we use precision balancing and we start working with precision, right? How often are we going to see this particular failure or that particular failure, right? So it comes to saying, I go back on that PF curve, go back into the design phase, go back into the time when it's installed and start talking about failure modes as they occur, as opposed to failure modes that we institute over and over and over again because we don't do the right things. So that's twofold. You need the technologies, but you also need to talk about, let's do things right to begin with, right?
Yep.
Go
Just
ahead.
wanted to mention a couple of things, Doug, before we run out of time. You know, there's those 6 graphs out of RCM charts that, you know, the infant mortality curve, the PM curve, you know, time, you know, after a certain period of time, you go into wear out zone and so on. You know, a couple of things about those graphs. Number one is almost all of them have a period of time in them where there's a constant conditional probability of failure.
Yeah.
In fact, depends on which study you look at, but it's about 90% of the equipment out there. At some point over its life, it will have a period of time where it has a constant conditional probability of failure. Well, what is that? Well, it's a random failure pattern. And how do you manage a random failure pattern? You have to do condition monitoring to detect the pending failure. So that's one thing. And if 90% of the equipment has it, then you better have a really comprehensive condition monitoring program or process, which includes operators as a part of that. And the second comment is, you know, there's a time scale on the bottom, but it doesn't give you the time. So I've been asked, and you probably have too, how long is the infant mortality period? Well, I don't know. Might be 5 seconds, might be a year.
Yeah.
Depending on the equipment and how it's operated and its failure modes. So those are what strategy graphs. They're not literal graphs that you should take and try to run with. They'll tell you where the greatest risk of failure is. They'll tell you about the need for condition monitoring, but each one of those has to be adapted into your particular situation. So I just wanted to make that point. You and I wrote a paper about this, if you remember.
Yeah, not too long ago.
Well, it should be published here in the next, whatever, month or so, finally. So anyways, back to you.
All right. So, yeah, you have to be involved in the technologies. I'm also a person that, you know, it all depends on your company size. whether or not you should have this in-house or whether you should hire somebody to come in and do it for you. I grew up, I did my time as a tradesperson in a large company. We had that stuff in-house and it worked out great. I've also done some work with smaller companies that use contractors to do it, and they were perfectly happy. It still comes down to, if this is going to work, the people that are doing it need to communicate well what's going on, right? And the folks that are taking that and getting that information need to understand that there is no defined time frame, as you just pointed out. That when they say, hey, your bearing is in alarm, you need to start to plan and schedule to replace that. Find the nearest window of opportunity, whether it's a week from now or a month from now, but it needs to be done, right? Stop asking, how much longer do we have, right? The biggest mistake I see with companies doing that is then they'll turn around, they'll spend more money and say, well, we used to have that guy come in here once a month now, and now we want him to come in here every week and look at that so that we know how bad it's getting, right?
Mm-hmm.
Well, guess what? If that's your strategy, you can plan on the fact that between those weeks and between those days, it's going to fail, right? Don't ask me which week, don't ask me which day. But if that's your strategy, it's going to fail. Whereas if you said right from the day that he told you, let's take a look at the calendar and figure out when we can do that as soon as possible, and you got it done, it ain't going to fail. All right. So
If you do
take
it right.
the proactive approach. Do it the correct way. Right. Outside of that, I continue to tell people RCM can be very easy. It's really simply a function of leadership and discipline, right? If you can put those two things together, it's no more difficult than root cause analysis. It's simple. Put the right people in the room, ask them the right questions, get a good facilitator that knows how to keep the group focused and on track, right? And attack that implementation as soon as you can and get that done. If you do that, you'll find that RCM is a relatively easy tool to use. Don't be afraid of it. It doesn't have to be that resource consuming monster. And I'm also a person that said, hey, look, yeah, I went and I took a couple different training courses. I read a bunch of books and I started experimenting on my own. If you got somebody in your group that's got their own internal drive, why bother hiring somebody? Let them go at it. Right.
Yeah.
Don't be afraid to invest in your own people. Right.
Yep.
Because
one thing I wanted to touch on is a little bit of an RCM logic tree before we, hang it up here. And real quickly, let me just give you the 3 or 4, rules for the folks out there. Should you do an RCM analysis? Well, if it has no effect on safety, health, environment, production, or equipment, no substantial effect, then you run to failure. Okay.
Right. Yeah.
If it does, then you question, is there a condition monitoring methodology that will allow you to detect it early enough to minimize the consequence? Well, then if so, then that's what you do. If not, then is there some sort of time-based approach that you can take based on consequence that'll help you minimize it? And if there's nothing there to help you manage a failure mode, then you may have to either redesign the system to allow for that or accept the risk and run to failure. So it's a fairly simple logic tree in here about doing RCM analysis. So did I miss anything on that, Doug?
I don't think so. And we are pretty close to our wall here. So I don't see any questions, which surprises me.
Oh, well, we're so good, we answered them all. Or maybe not. Yeah.
I had one that came in on LinkedIn the other day that just as we sat down to do this, I said, "Oh gosh, I haven't got back to that fella yet on the question that he had, which was a formula on determining beta and eta in terms of failure rates." And yeah,
Yeah, well, that's above my pay grade or intellectual grade, I'll say, you know. But,
let's just say that that's stuff that you hear and you read and you see a lot about, and occasionally somebody even speaks about it at conferences. And I tell the folks that I trained, I haven't done those calculations since night school.
Yeah. Well,
if I were, as you talked about, if I were sending somebody to the moon or working on a plane that we're about to, fly across the Pacific, then we'd start talking in those terms. But most manufacturing facilities, it is really a question of, has it failed? Will it fail? Can we detect it? If we can't detect it, can we prevent it? If we can't do those things, if it impacts safety, then we need to talk about redesign.
Yeah.
So life is pretty simple in terms of manufacturing. So at any rate, Ron, it's been great talking with you again today.
Yeah, likewise, but I want to repeat something. What's it supposed to do? What's stopping it from doing that? What's hurting you the most? And what are you going to do about the things that are hurting you the most? So there you go. That's my hillbilly RCM yet again.
All right. And if you want to learn more about it, there it is. Pick
Doug's
that up
book.
And read it.
It's a good one.
Well, yes, guys, we do have one question in.
Came
in. Yeah, you're good. They are asking, are RCM, FMEA, and FMCA all the same thing? Or are there
That's a good question. There are a lot of similarities between the three. It's really a fine-tuning thing in terms of the differences. RCM is typically, again, deals with what could happen and what are we doing to mitigate it. FMEA is in my learnings and how we applied it when I worked at Kodak, that was something we did in the design phase of a project to understand potential failure modes and try to deal with them up front. FMEA is really the heart of what RCM is failure modes and effects criticality analysis, so that we understand the criticality of the failure modes, which ones are most likely, and in terms of probability and consequence. So they are all very similar. Ron, your opinion?
Well, I mean, I think of RCM as FMEA plus action.
Yeah.
So failure modes, effects, criticality analysis, plus what are you going to do to manage that, to minimize, to mitigate? So I see them as being very, very similar, but RCM equals FMEA, FMECA, I think, is that right? Yeah. Anyways, plus action task. So that's it.
All right.
Well said, guys. Thank you so much. Thank you again for your great time and session today. On behalf of the entire team at MOBIUS Connect, thank you to our wonderful audience for joining us too. Just as a quick reminder, you can see past episodes of Connect Conversations on YouTube, and we will share the link to subscribe to our YouTube channel in an email following this webinar. Be on the look. Our next conversation is all going to be about managing cultural change, and that will be on March 15th. So look out for a registration link there. And if you're interested in engaging with other industry professionals or would like to participate in the industry's live feed and forums on MOBIUS Connect, you can visit mobiusconnect.com to create your free profile. And be sure to follow us on social media at MOBIUS Connect to stay up with the latest community happenings. If you have any questions at all, you are welcome to email our MOBIUS Connect team at info@mobiusconnect.com. Thanks again for joining us. Have a great day, stay safe, and we will see you next time.